continuing with nomenclature, now we do naming of compounds having two like groups. In such cases, what we do, we will count the number of both carbons. This is a 4-carbon system now. It will be named as butane 1,4-dicarboxylic acid or dioic acid. So if there are two functional groups, they are same, then carbon of both the functional group, that should be counted. 1, 2, 3, 4. This is butane 1,4-dial, for aldehyde. Similarly, we have CN group. This is pentane, 5-carbon system. Carbon of both functional group, they are counted. Pentane 1,5-dinitrile. So when two similar groups are there, their carbons should be counted in the selected chain. This is COOH, CH2, COOH. This will be propane 1,3-dioic acid. Similarly, if we have this system, this is butane 1,4-dioic acid. Similarly, we have more CH2 group here. Its common name is succinic acid, you might be knowing. Then we have 6-carbon-dicarboxylic acid. It is commonly called as adipic acid. IUPAC name is hexane 1,6-dioic acid. So till we are having two similar groups, the same group present twice, then carbon of both the groups, they should be counted in the selected chain and then they are numbered. Now if there are three similar groups and they are present in the selected chain, then none of the carbon of the functional group is counted in the parent chain. Parent chain, that is to be taken of the saturated carbons, and these functional groups, they are not dealt as substituents. So this will be our fourth part, naming of the compounds having more than two allyl groups. In such cases, we don't consider the carbon of these functional group during change numbering, but the alkane chain is numbered and these groups, they are taken as substituent. This is 1-carboxylic group. This is another carboxylic group. This is third one. So now this case, none of the carbon is taken in the chain. Our chain is, parent chain is 5-carbon system. Carbon number 1 having carboxylic group, 2, 3 is having carboxylic group, and 5 is having carboxylic group. So it is pentane 1, 3, 5 tricarboxylic acid. So the carbon has not been counted. Carbon of functional group, that has not been counted. Now all of these functional groups, they are attached directly So their carbon is not counted in the chain. This is propane. 1, 2, 3 tricarbaldehyde. Now we come to the system where we have three functional group, alike functional group, but one of the functional group is present in side chain. Then that is not considered here as a attached to chain. It is not attached to parent chain. It is attached to side chain. So this is a substituent now. Now the carbon of both of these, they should be counted because it is two functional group compound now. So we have pentane 1,5 diol, and this is formyl methyl at 3 position, 3 formyl methyl, 3 formyl methyl pentane 1,5 diol. So in such cases, the carbons of the functional groups, they are counted, and this carbon is not counted. Similarly, we have another system. Now this is functional group is present in the side chain. So this is our parent chain. It is 6 carbon chain. 1, 2, 3, 4, 5, 6. So it is the substituent on carbon number 3. This is 2, this is 1, 4, 5, 6. This is carboxy, 3 carboxy methyl. And parent chain is 6 carbon chain. Hexane 1,6 dioic acid. So this is the numbering of those compounds where more than two functional same functional group is present twice or thrice in the chain. But if one of the functional group is present in side chain, then the groups which are coming along with selected chain, they are considered as the parent group, while side chain group, that will be dealt as a substituent in this case. So this is regarding the compounds which are having two or more than two alike groups. Now we'll name the compounds which are having more than one kind of functional group. So this will be now our fifth system, naming of the compound which are containing more than one kind of functional group, having more than one type of functional group. So in this case, we follow priority table. According to that, most reactive functional group is SO3H. If it is taken as the substituent, then prefix of this group will be sulfo. If it is taken as parent, then its suffix is used in the end. It will be called as sulfonic acid. Then we have second functional group. This is COOH. It is carboxy oic acid. Then we have derivatives of carboxylic group, COOH. Its derivative is acid anhydride, COOR. So let us take first of all acid anhydride, that comes third in the order of priority. This is acid anhydride. It will be called as oic anhydride. Suffix is also taken as oic anhydride. So after this we have ester linkage COR. It is prefix is alkoxy carbonyl. Parent name is alkyl alkanoate. This is alkyl, this part will be OH, alkanoate. After COR, we have the group COCl, CONH2 and cyno. This is haloformyl, chloroformyl. This is carboxamido. This is cyno. This is oil halide, oil chloride, carbamyl. Carbamyl will be taken here, carboxamido or amide will be taken here. Then cyno is taken as nitrile. So this is 7th in the order of priority. After this we have CHO, CO, OH, NH2. This is formyl alkanal. This is oxo on butanone pentanone. This is hydroxy. This is all. This is amino. This is alkanamine. Suffix is used after the parent alkane name. E is removed and amine is added in the end. Then we have ethers in the last. They are called as alkoxyalkane. Here we name alkoxyalkanes. Then we have few groups which are always delta substituent. They are halogen for Huckleberry along with NO2, NO, OR and R. All halogens. Then we have NO, NO2, OR, always as substituents. So these groups, they are always dealt as substituent. They are never been made parent. Alkyl group is also included in this series. So they are always dealt as substituent. They are never been the parental groups. So in this manner we'll be naming some compounds which are having these functional groups. Sometimes they have single functional group out of these groups, sometimes they are having more than one group. So in this case, priority order, order of seniority, that must be followed. So first name we have chloroethane sulfonic acid. 1-chloroethane sulfonic acid. In this case, 2 carbon chain is made. 1 carbon, put chloro here, SO3H. This is 1-chloroethane sulfonic acid. Then we have second system, which is having formyl group as well as carboxylic group. So this is our system. 1, 2, 3, 4. 2 carbon is having formyl. 2 formyl butane oic acid, butanoic acid. So it is carboxylic group which is given preference during the numbering. Then we have anhydride compound CH3 CO CH3. This is 2 carbon acid derivative. It will be called as ethanoic anhydride. Two molecules join together by losing water. This molecule is called as anhydride. This is ethanoic anhydride. Then we have already done this. CONS2 group 1, 2, 3, 4, 5. So this is pentane, pent-3-ene, 2-ol, 1-amide, or 1 can be left, olamide. This is the compound having 3 functional groups in it. Then we have the naming of the substituted cycloalkanes, substituted cycloalkanes. They have this type of system. This is not there. It will be named as 1,2-dimethyl cyclohexane, 1,2-dimethyl cyclohexane. Then we have 2 cyclohexyl group attached to CH2 system. This is parent alkane. This is dicyclohexyl methane. There is no need of numbering since this system has only 1 carbon. Numbering is done if it has more than 1 carbon. Then we have few more system. Here the cyclic system is joined to a non-cyclic system. Then how to name these compound? This is 3 carbon cycle. We have 4 carbon in this outer cycle. So the system having more carbons is given as the parent alkane. 1 carbon is having cyclopropyl. So 1 cyclopropyl butane. So in this manner the naming of these compounds that is done. If the functional group is present in the cyclic compound, then that compound is taken as parent. And it is numbered from that end, which gives lowest number to the substituted carbon. This is cyclohexanol, and carbon number 4 is having 4, 1 propyl, cyclohexane-1-ol. So this is the naming of compounds which are having more than 1 kind of functional groups. Then we have few more compounds which are having the cycle as well as functional groups are there. Let us draw a cycle. This is our first compound to be named. Then we have another. This is second compound. Then we have third compound. Having ketonic group in the cycle as well as OH group. This is our fourth compound. Then we have fifth compound. It is cyclopentane having amide group as well as that of methyl group. So these are few compounds, how to name them. This is the compound where double bond is present. We will number it from this end. It is 3-methyl cyclo X1 in this case numbering is done from here 1 2 3 3-ethyl cyclo X1-enol. This is numbering is done from this end. This is cyclohexanol 3-hydroxy cyclohexanone. This is numbering is done from this end. This is 3-oxo cyclohexanoic acid. Hexane carboxylic acid will be better name here. Hexane carboxylic acid. Because its carbon is not counted, therefore oic acid should not be used there. Now we come in this case 2-methyl cyclohexane carboxamide. That is 1 carboxamide or carboxamide. Now in this case numbering to be done from here 1 2 3 4 5 6 3 5 dimethyl cyclo X1. So these are the mixed systems. Then we have some bond line notation of the compounds. One, two, three, four, 5, 6, 7. It is hepta 1, 3, 5. Triene. Then we have this compound. This is having 3 methyl groups on it. So longest chain to be taken propane 2-methyl propane 2-ol. Then we have this compound. Numbering is to be done from that end. 3-methyl. This will be the methyl group. If you complete the valency, this will be methyl group. So it is 3-methyl penta 1,4 diene 1-ol 3-ol. So in this way bond line notations of the compound they are also named. Then we have the naming of bicyclic systems. This will be our 6th part of the nomenclature. Naming of bicyclic systems. So how the bicyclic, the systems having 2 cycles in them, attach the bicyclo word before their name because they are having 2 cycles, and then in the bracket write the number of carbon atoms of the 2 cycle followed by the number of carbon in the bridge. This is the way how to name these compounds. First of all we have this bicyclo compound. So to write its name, we first of all write bicyclo. Now this is one cycle, this is another cycle. Both of them, they are having one carbon. So 1 1, this has no carbon because this joint carbon does not participate in the numbering, so it will be having 0. Now count the total number of carbon. This is a 4 carbon system, so bicyclobutane. Similarly, we have another system. It is a hexagonal system. Now bicycles are there, but each cycle is having 2 carbon, 1 2 1 2 1 2, and total carbon they are 6 carbon, 1 2 3 4 5 6 7 8. We are having 8 carbon. So this system will be a derivative of octane, bicyclo 2 2 2. Octane. Since this cycle contains 8 carbons, then we have this is again bicyclo system 1 2 3 4 5 6 7. So this is bicyclo. It has carbon 3, it has 1, it has 1. 3 1 1. Then we have heptane. Then we have another system. It is having double bond. In cyclo, it is now cyclohexane up to now. Now it will be changing. This is having 2 methyl on the central carbon, and it is having methyl group at carbon number 1 also. This is methyl. If we complete the valency, we will be writing C. 3 hydrogen will be attached to satisfy the 4 valency of carbon. Now this is also a bicyclic compound, and it is having 3 methyl group as a substituent. So numbering of this chain is done in such a manner that this substituent carbon should get the lowest number. 1 2, this is 1 carbon. Now it is longest cycle is here first. This is the number from this system 1 2 3 4 5 6, and then we come to the joint 7. So now the group position are so this is 2,6,6 trimethyl. So after going at this position, we come to this position. It is 6th position, and this position is numbered then separately. Then now it is 2 carbon having methyl, 6 carbon having 2 methyl. So you will be writing 2, 6, 6 trimethyl. Then you write bicyclo. How many carbons are present in each cycle? 1 2 3 in this cycle, 1 in this, 1 in this. So you will be writing 3 1 1. 7 carbon system it will be heptane. So in this manner this compound is named. It is hept 2-ene. Double bond is there, hept 2-ene will be the correct name of this. So this is the naming of bicyclic systems. Then we have another system. These are cyclopropyl group joined through carbon number 1, carbon number 1 dash. 2, 3 will be counted later on. So this is 1, 1 dash bicyclopropane. 1, 1 dash bicyclo, 2 cycles are there. Propane. will be counting only one carbon. Why means two cycles of similar types are there. This is 1,1 bicyclopropane. Then we have three phenyl groups joined together. This is one dash. This is one double dash. So we'll be writing 1 dash. Then we have 4 dash. 4 dash. 1 double dash. Terphenyl. These are three phenyl groups which are attached to the different positions. 1141 terphenyl is the name of this compound. Then we have three cyclobutyl systems. These are three cyclobutyl systems. This is 1 dash, this is 4 dash, this is 1 double dash. So you will be writing now 1 dash, 4 dash, 1 double dash, terp, cyclobutane, or we can call it as cyclobutane in this case. So this is the naming of the systems which are having two cycles in them. So this is all about the nomenclature of the organic compounds.